Imagine this for a second. A man and a woman are diagnosed with the exact same condition. They go to the doctor and they're prescribed the exact same medication at the exact same dose. But while the man gets better, the woman suffers a severe, life-threatening reaction. It's crazy, right? If we're treating the exact same disease, why in the world does the biological sex of the patient change absolutely everything? Well, welcome to today's Explainer. I am so thrilled to guide you through some truly mind-bending data today. For centuries, medicine basically operated on this one-size-fits-all model. It treated the male body as the default standard for all humans. But then, in 2016, the National Institutes of Health released a massive landmark mandate. They demanded that scientists start treating sex as a biological variable in all vertebrate animal research. And honestly, that policy officially ended the era of one-size-fits-all medicine, and it cracked wide open a world of staggering biological paradoxes. Okay, let's dive right into this fascinating journey. We'll start by defining sex versus gender in medicine, then we'll look at cardiovascular health, the brain and mental health, immunity and hormones, and finally wrap up with pharmacology and viral infections.
Starting off with Section 1, Sex versus Gender in Medicine. Let's get our foundational vocabulary down.
It is absolutely vital that we clearly distinguish between these two terms right out of the gate. A sex difference refers to pure biological traits, things conferred by your chromosomes and your hormones. For instance, women biologically have a slightly longer QT interval in their heartbeat. Keep that in your back pocket, because that is going to become incredibly important later on. A gender difference, on the other hand, involves psychosocial roles and cultural expectations. Think of the data showing that women are actually less likely to call 911 for their own chest pain. And here is a crucial clinical pearl to keep in mind as we look at disease rates. In 2021, women lived an average of 5.9 years longer than men. So what does that mean? It means when we see a female predominance in age-related diseases, like Alzheimer's or hypertension, it's partially just a demographic effect of aging, not solely a biological mechanism. Moving right along to Section 2, cardiovascular health and risks. There are some incredibly dangerous misconceptions here. Here is a classic trap that even seasoned doctors fall into: the Hollywood heart attack. You know exactly what I'm talking about. When we picture a heart attack, we immediately imagine a man clutching his chest in sudden, crushing pain. But in reality, women present entirely differently. Their initial symptoms are often highly atypical. We're talking about profound fatigue, shortness of breath, nausea, or even just indigestion. Classic chest pain is actually much less common in women. On top of that, women typically present with these cardiovascular issues a full 10 to 15 years older than men do. Missing these atypical symptoms has historically cost a lot of lives. Which brings us to a truly shocking statistic: 6 times. Why is that number so important? Well, female sex hormones, particularly estrogen, are highly cardioprotective. Estrogen does amazing things. It increases your good cholesterol, decreases the bad cholesterol, and improves insulin sensitivity. But, and this is a massive but, if a premenopausal woman develops diabetes, she loses all of those cardioprotective benefits of estrogen. Literally gone. This leads to a staggering 6 times greater risk of cardiovascular mortality compared to women without diabetes. Basically, her cardiovascular risk profile instantly becomes identical to a man's. And this brilliantly illustrates one of the strangest inversions in all of cardiology: Takotsubo syndrome. You might have heard it called broken heart syndrome. It's a stress-induced cardiomyopathy. Postmenopausal women make up an overwhelming 80 to 90% of all cases. They're vastly more likely to get it. But here is the paradox. Men who get it suffer significantly higher mortality rates from cardiac shock and arrest. So women get it way more, but men die from it more. Mind-bending, right? All right, on to Section 3, the brain and mental health. Let's look at some really stark biological contrasts. Take the ApoE4 allele. This is a major, well-known genetic risk factor for Alzheimer's disease. But here's the catch. It does not behave the same way in everyone. In women, carrying this allele is strongly linked to the progression of sporadic Alzheimer's disease and severe cognitive impairment. In men, however, the exact same genetic allele has only a marginal impact on their memory or cognition. Let that sink in. The exact same gene ravages a woman's cognition while leaving a man's largely intact. Now, we need to correct a massive clinical misconception regarding mental health. It is a biological fact that women face double the risk of major depression compared to men, and that's a sex difference that starts way back in early adolescence. Because of that, there's this widespread myth that the incidence of major depression must spike dramatically during menopause. But actually, that is entirely false. the incidence of major depression actually decreases after age 45. So, to quickly summarize these clinical pearls, Alzheimer's disease is about twice as common in women, which is heavily linked to aging, that APOE4 gene we just talked about, and the sudden decline of neuroprotective estrogen. But then look at Parkinson's disease. Men are 1.5 times more likely to develop it. Why? Because the SRY gene, which is located exclusively on the male Y chromosome, directly upregulates the specific neurons involved in Parkinson's. It's built right into the genetics. Similarly, ALS shows a very strong male sex predominance. Let's move to Section 4, Immunity, Metabolism, and Hormones. The risk profiles here get incredibly complex. Get ready for an absolutely wild paradox. We all know that hormones regulate body fat, but look at how testosterone, which is an androgen, behaves. In women, having high levels of testosterone increases dangerous visceral abdominal fat and directly drives up the risk of type 2 diabetes. But in men, having high testosterone actively prevents abdominal fat and decreases their diabetes risk. It is literally the exact same hormone, driving completely opposite metabolic effects based entirely on the host's biological sex. No way, right? And hormones dictate our immune system too. Estrogen actively stimulates the cellular mediators of immunity. It's essentially like a turbocharger for the body's adaptive immune response. Now, because of this, women are vastly more susceptible to nearly all autoimmune diseases. We're talking Graves' disease, Hashimoto's, rheumatoid arthritis, lupus, MS, and ITP. They all show massive female predominance. Interestingly, one of the very rare exceptions to this rule is type 1 diabetes, which actually affects men and women equally. Beyond just internal biology, we have to look at external environmental and clinical risks because they heavily impact the outcomes we're discussing. The data shows that maternal mortality in the USA is higher than in other industrialized nations. Further, the source data notes that state-level restrictions on abortion are statistically linked to a 62% higher maternal mortality rate. Additionally, looking at intimate partner violence, it affects approximately 15% of women compared to just 4% of men. These severe external factors create massive physiological and psychological impacts, which sharply increases the risks of depression, substance abuse, and suicide for those affected. Finally, let's hit Section 5, Pharmacology and Viral Infections. How do our bodies react to external invaders? Well, the simple truth is that women experience a much higher frequency of adverse drug reactions overall. Why? Because women, generally speaking, have lower overall body weight, a higher percentage of body fat, less total body water, and totally different pharmacokinetics. And by pharmacokinetics, I just mean how the body absorbs and processes chemicals. Because of this physiological makeup, women suffer much faster and much harder from certain toxins. For instance, women develop alcoholic liver disease at a much shorter duration and lower dose of alcohol than men do. Similarly, women with HIV experience a much more rapid decline in their CD4 immune cells, and they suffer way higher rates of side effects from the antiretroviral drugs used to treat the virus. So, a absolutely crucial point is how we manage these pharmacological risks. Hey, remember back at the very beginning when we noted that women biologically have a slightly longer QT interval in their heart rhythm? Okay, because of that tiny biological difference, women are at massive risk for a fatal, drug-induced arrhythmia called Torsades de Pointes. In fact, 2/3 of all cases of this occur in women. To help remember the culprits, medical professionals use the AAA mnemonic. It stands for antihistamines, antibiotics, antiarrhythmics, and antipsychotics. These 4 incredibly common drug classes block cardiac potassium channels. And in a female heart that already has a prolonged repolarization phase, taking these can literally be deadly. And let's look at how sex differences play out in a massive global pandemic. Looking at the 2020 COVID-19 data, we see a very clear gap. Mortality was 10.9% for men and 9.8% for women. Across the board, men suffered significantly higher incidence, higher hospitalization rates, more ICU admissions, and worse overall mortality. And that was true across all age groups, races, and continents. So, what's the underlying biology of why men fared so much worse with COVID-19? It actually comes down to viral entry mechanisms. The virus needs certain cellular proteins just to enter our cells. Estrogen actually reduces the expression of the ACE2 receptor in the heart and kidneys, so it effectively removes the virus's entry points, acting like a biological shield for women. Male androgens, however, actively increase the expression of a protein called TMPRSS2. This protein is heavily concentrated in prostate tissue and is strictly required for the virus to prime itself. So male hormones are literally rolling out the red carpet for the virus, which perfectly explains the vastly worse outcomes for men.
Wow, we have seen today how something as fundamental as the ApoE4 gene, a single testosterone molecule, or even a completely standard antibiotic can behave entirely differently depending simply on the biological sex of the patient. Understanding these staggering biological paradoxes isn't just fun trivia. It is quite literally a matter of life and death. So I want to leave you with this provocative thought. Armed with all this amazing data, is one-size-fits-all medicine finally a thing of the past? And how will you use this knowledge to advocate for your own personalized, sex-aware medical care? Thank you so much for exploring these vital clinical realities with me today. Keep asking questions, keep looking at the data, and we will see you on the next Explainer.